Hi, I'm from Social Research Insights, and today I'm going to explain you how to do cross tabulation in PSPP. The mission of Social Research Insights is to promote open source software for data analytics for both academic and corporate needs. And in this video cast, I'm going to show you how to perform cross tabulation through PSPP. I'm going to do that in 3 steps. In step number 1, I'm going to create or simulate the dataset with the help of PSPP syntax, as usually as we do it in SPSS. The same, all those operations which we can do in SPSS syntax, we can do all those operations that we often perform in SPSS syntax in PSPP syntax. So after creating after simulating the dataset, I record the data and assign value labels, and both create simulation of the dataset and assigning the value labels. I perform that through PSPP syntax, and after that I will show you how to perform the cross tabulation. I already have a sample code which I usually use while to simulate the datasets. In case if you would like to know the meaning for this code, you perhaps have to see my other video on simulating the datasets through PSPP. Okay, the first part of the dataset deals with the simulation, and the second part of the dataset deals with setting value labels to the data variables. So I'm going to create the 10 data variables with 100 data points. I mean my capital N is going to be 100, and there will be 10 data variables in my dataset. And after that, after I record the variables, I mean after setting the value labels, I shall perform and explain you how to interpret the data once we get the measures of cross tabulation. Okay, so to execute this code, you just have to go to the run and select all, press enter. So we have the dataset with 10 data variables and 100 data points, I mean the cases. If you would like to verify or check whether our code has set up the value labels for these data variables, you just have to go to the variable view, just usually as we have 2 types of view, data view and variable view, just like we do in SPSS. So the same thing we can also do it here. I have to go to the variable view to check whether my data variables are assigned by the label variables. So here you see, if I want to do this manually, it will be very difficult for me to assign these labels for each and every variable. So I have to do that 10 times multiplied by 5, I mean 50 times I have to enter the values through this window. So it is better to go through the syntax, use the full capability of PSPP. I mean instead of entering 10 multiplied by 5, which means 50 times the data labels, it is better to write the 5-6 line code and execute through the syntax, so that all the variables automatically will be assigned by the data labels. In this case, I am going to assign the label highly satisfied to 1, and highly dissatisfied to 5. Okay, so I should have, so we have only 4, so I have only 1 to 4 it seems. Yeah, there is no 5, only 4. Yes, there is also 5. So there must be the 5th item. I mean this data actually, yes, there is 5. This data actually measured through Likert scale with 5 5 anchors or items, Likert scale, where 1 stands for highly satisfied and 5 stands for highly dissatisfied. So that is actually the scheme of the measurement for this data set, and I'll go back to the data view. Now as we have set up the value labels for all the variables, so we are ready to go for the data analysis. In PSPP there is a wonderful menu item analyze, just like in SPSS, where the very first sub menu under the menu analyze we have four options for descriptive statistics, that is frequencies. I mean, we can compute the frequencies, descriptive statistics. We can also explore the by computing the few measures, and we can also perform the cross tabulation. So in this case I'm going to show you how to perform the cross tabulation, as I have mentioned in my introduction to this video. So in case if you would like to perform the cross tabulation, you just have to press enter, and the same SPSS like pop-up menu will appear for our analysis. In this case we are going to do the cross tabulation for the first two variables. Doesn't matter what the name what names these variables might have been with, but this is a sample demonstration, so it doesn't matter what names that we are going to deal with. I mean, it doesn't matter the names of the variables, we just have to compromise with x1 and x2, whatever it may be, like x1 stands for age and x2 stands for income, or x1 vice versa. But in this case it doesn't matter the order of the, but you just have to know the rows and columns of the variables. In case if you have the number of items in more compared to the number of items in items from the first variable, I mean, it is better to keep the variable which has a lesser number of the items in rows and more number of items in columns, so that the table will be rather good to view and interpret. Okay, I'll go to the statistics, and I have so many statistics, and I do need to know what type of data I'm dealing with before going to choose this the sample statistics. Right now this is ordinal data. Chi-square statistic is a generic measure which can deal with any type of data, but there are a couple of other measures that are very specific to the nature of the data, so we must be very much mindful while choosing the measure for data. So in this case I have the ordinal data set, so I need to go for either lambda, tau or gamma. Maybe there is also correlation here, you can see, and you can also choose none, so that there will be nothing in your output. So in this case I'm just going to choose chi-square, which is a generic measure for almost all types of data. I press continue, and I can also go for the format and print tables, print pivot table, ascending order, or whatever it may be. So these are all checked here automatically. I need not worry in choosing these options. And you can also paste this code in case if you would like to run this activity through syntax. And there is also an option for the cells, and you can choose what cells if you want expected frequencies. If you also want to have the residuals, you can go for the residuals. You can also choose the standardized residuals, adjusted standardized residuals, and etc. So in this case we just let us compromise to the count, I mean the numbers, frequencies, row and columns and totals. So that's sufficient for, and I can also choose and residuals in case if I am interested for the further analysis. But in this case this is a very simple demonstration, so I'm not going to worry too much about my output table. So I just press continue, and finally I just press OK, and let's go to the output window, and let's see what is ready for me for analysis. Okay, beautiful. So here, see here, the output table is displayed in the form of the labels that I assigned to my variables. As I have said, highly satisfied is 1 and highly dissatisfied is 5, and these are the summary statistics for the cross tabulation. And we can pick up the percentages, like highly satisfied and highly satisfied, how many number of there are 3 individuals in these two variables, and to the tune of 13.6%. from the total sample, um, I mean, I can say there are 13.6 percentage of the sample respondents uh, mm, who belong to the category highly satisfied and highly satisfied. I mean, those individuals whose response is highly satisfied in X1 uh, and highly satisfied in X2 are indeed 3, and it is that they account for 13.6%. So this is the way. So if you look very closely, there are the number of individuals are rather more in the third category. I mean, the individuals whose response is indifferent in second variable, and the response highly satisfied in the first variable are in fact 9, and the percentage is 40.9. So in this way we can just interpret this I mean the cross table for the first two data variables, and I can pick up some, I think see this is the total row, I mean the row that shows the total frequencies. I think 12. This is the indifferent and dissatisfied. There are 12 individuals whose response is indifferent for variable 2 and dissatisfied in variable 1 for variable 1. So there are 40%. This is rather a special case in our analysis. And these are the significant test for chi-square significant test for study variables x1 and x2. And if you observe the Pearson chi-square measure 11.58, and the null hypothesis is accepted. In other words, we don't have sufficient evidence in the data in support of alternative hypothesis. For my p-value, two-tailed p-value is 0.77, and so how can we interpret this value is rather more important compared to just taking these output tables and pasting it in our reports. So we just have to take the concerned measure from the output and pick up the p-value for that particular measure and compare the p-value against a 5% significance level, which means 0.05, and here the p-value is greater than 0.05. So we are actually accepting the null hypothesis that the variables under study are independent. The respondent's response or response towards x1 has nothing to do with response towards x2. In case if my x1 is the age and x2 is satisfaction, the satisfaction has nothing to do with age. So that is the way we need to interpret the data. In case if x1 is income and x2 is satisfaction, the satisfaction has nothing to do with the income. It doesn't depend on income because we are accepting the null hypothesis. So the null hypothesis favor the independent relationship between the study variables. So the variables under study are in fact independent. They are not dependent on each other. So there are a couple of other measures which I will try to explain you in my next video cast. Thank you.